So, here's the question that you asked. A curve is such that dy dx is equal to 2kx minus 1 cubed, where k is a constant. I think your question is, given that the curve passes through 0, 1, find the equation of the curve. I'm going to assume that that's it. So basically, what you've got is that you want to find the y, which is the integral of this two lots of kx minus 1 cubed dx. Now, there are two ways of doing this. The first way that I haven't shown you here is to look at kx minus 1 and expand it, do kx minus 1 times kx minus 1 times kx minus 1, so that you get a cubic expansion, and then you could integrate each term. What I'm going to show you here is what happens if you use integration by substitution. So that means you're going to let the u be kx minus 1. So kx minus 1 here is going to be replaced with u. And because you're doing this substitution, if you differentiate u with respect to x, you get du dx is equal to k, because k is a constant here. And that means that when you go through to differentiate, to look at this thing, to rearrange it, you can get that du over dk is equal to dx. And you're going to use this and that to rewrite this expression all in terms of u. So that's 2, that's the 2. This is u cubed, so there's your u cubed. This thing here is u cubed. And the dx, remember here, is the same as du over k. So what you've got, if you work through this, you've got the 2 over k, take this out as a constant, and then you've got u cubed to integrate with respect to u. So integrating u cubed is a quarter u to the 4th. And you've got a constant. So the 2 cancels with the 4, so you get 1 over 2k is equal to the u to the power of 4. But you know that u is kx minus 1. So you've got kx minus 1 to the power of 4. So your y is equal to this expression here. Now, what you've got here is that if x equals 0, y is equal to 1. So 1 here, x is equal to 0 means this disappears, and you've got minus 1 to the power of 4. Minus 1 to the power of 4 is just plus 1. So you've got 1 is equal to 1 over 2k plus c, which means that the constant of integration is 1 minus 2k. And you can now use this expression here back in here to have your complete curve, because that c gets replaced. And there's your answer.